Here we go. We have a question: minimum operations to make binary array elements equal to 1, part 1. So you are given a binary array nums. You can do the following operation on the array any number of times. We need to choose any 3 consecutive elements from the array and flip all the elements, right? And the flipping an element means changing its value from 0 to 1 or from 1 to 0. So we need to return the minimum number of operations required to make all the elements in nums equal to 1. If it is not possible, return -1. So we have given this array, and first we have given this array, and what we gonna do? So this element is 0. We want this element to be 1 itself. So we need to flip it. So this will flip 3 consecutive elements. So we got this, right? So we got this array. Then the next element is this, which is 0, but we want 1. So we need to flip 3 consecutive elements. So we have flipped the 3 consecutive elements. Then the next element is 1 only. Then the next element is 0. So we need to flip it. So it will flip the next 3 elements, right? So then we are on to the next one. This is already a 1. Then the next one, it is already a 1. Then if we go to this array, first the element is 0. We want 1. So what we'll do? We have 1. So we need to flip it. So we are doing an operation. So this will be 1, 0, 0, right? So then in our next iteration we are on to this, but this element is 0. So this element is 0 as we have done an operation. So 0, 0, 1 is the remaining array. This element is 0. So this element is 0, we want 1. So we will flip 3 consecutive elements. So this will flip 1, 1 and 0, right? So we are on to this. This is already 1, but the next element is 0. We need to flip it, but we don't have next 3 consecutive elements. So this will create an issue. So we cannot change, we cannot make all the elements in this array equal to 1 itself. So the answer in this case is -1. So this is a greedy question, and this is a very simple question. I don't know why it is marked as medium, but this is a simple question. What we gonna do? We have just I, and we have n. Then we also need answer, which is to track the number of operations we have done, right? So we have this while block I less than n. So if the ith element is 0 or the ith element is 1, if the ith element is 1, what we gonna do? We are on to the next index. If this is 1, if this is 0, if this is 0, we need to flip. So we need to do an operation. So we have done an operation, and it will apply on the ith element, on the I plus 1th element, on the I plus 2th element, but I plus 2th must be accessible. So I plus 2 must be less than n. If this is case, we need to flip it, but if this is not the case, so suppose we have only given one size array, so I plus 2 is not accessible. So in that case, we cannot create all the elements equal to 1. So this is not possible. We just gonna need to convert to -1. So we just gonna return -1. Then we need to flip I plus 1th, I plus 2th and ith. So as we are directly going to I plus 1th index, so I think there is no need to convert ith element, because we are sure that ith element will be converted, right? So why need to write another line? So I will just do I plus 1th. If I plus 1th is 1, it will become 0. If it is set, it will become unset. If this is unset, it will become set. So we can apply XOR here on I plus 1 on I plus 2. Next thing is to jump on to the next index. So I plus 2 is happening here in the if block or in the else block, same, right? So we can cut it from here, cut it from here, cut it from here, and write outside it. So because I plus 1 is happening in both of the cases. Next, just read through. return answer. Let's run this and I hope it will work. Yes, let's submit this and it should work. And yes, working fine. Then let's discuss about the time and space complexity. So we have given this array and the time complexity of this array. What is the time complexity? Time complexity is order of n only. Space complexity is constant. That's all. Thank you all for watching.